So here in this problem, we're given that cosine of alpha minus beta plus cosine of beta minus gamma plus cosine of gamma minus alpha, that's given by negative 3 over 2. So using this particular information, we need to show that cosine alpha plus cosine beta plus cosine gamma, that has a value of 0. And so does the sum of sine alpha, sine beta and sine gamma. So let us begin. So we'll start with whatever we are being provided with. So here we are given cosine of alpha minus beta plus cosine of beta minus gamma plus cosine of gamma minus alpha. So this sum is equals to negative 3 over 2. Number 2. In each of the terms, we have cosine of alpha minus beta. So we have a difference of angles. So we can use the fact that whenever we have cosine of A minus B, so that expands to give us cosine of A times cosine of B plus sine of angle A times sine of angle B. We're going to use this fact to expand each of the three terms. So let's do that. So when we expand cosine of alpha minus beta, we're going to get cosine of alpha times cosine of beta plus sine of alpha multiplied to sine of beta plus we can expand cosine of beta minus gamma to get cosine of beta times cosine of gamma plus sine beta times sine gamma. Coming to the third term, we have cosine of gamma minus alpha, so that will become cosine gamma times cosine alpha plus sine gamma multiplied to sine alpha. So this is given. This is equals to negative 3 over 2. We will multiply both sides with 2. So we're going to multiply both sides of the equation with 2. So that means we will now get 2 times cosine alpha times cosine beta plus 2 times sine alpha times sine beta plus 2 times cosine beta times cosine gamma plus 2 times sine beta times sine gamma plus 2 times cosine gamma times cosine alpha. And we have 2 times sine gamma multiplied to sine alpha. And on the right hand side, we have negative 3 over 2 times 2. So 2 and 2 gets factored out. We are left with negative 3. So we'll transport that negative 3 to the left hand side. So we have positive 3 on the left hand side. And this will be equals to 0. Now, we are going to rewrite our expression. So we can split this 3 into 3 parts. And we can rewrite our expression as we'll consider the first term. So we will add 1 to it. So we have 1 plus 2 times cosine alpha times cosine beta. So this will be one particular term. Then we will take another 1 from this 3 and we'll combine with this, which is 2 cosine beta times cosine gamma. Right. And then we'll take the remaining 1 and combine it with 2 times cosine gamma times cosine alpha plus and the remaining term, which is 2 times sine alpha times sine beta plus 2 times sine beta times sine gamma plus 2 times sine gamma times sine alpha. So that's equals to 0. Now there's a reason why we wrote in this particular fashion, because we have a standard identity. We know for a fact that whenever we have sine squared theta added to cosine squared theta, that's equals to 1. So that's the Pythagoras theorem. So here we're going to replace this 1 with sine squared alpha plus cosine squared alpha plus 2 times cosine alpha times cosine beta. Coming to this next one, we'll be replacing with it cosine squared beta plus sine squared beta plus 2 times cosine beta times cosine gamma. And then this particular one will be replaced with cosine squared gamma plus sine squared gamma. And we are left with plus 2 times cosine gamma times cosine alpha and the remaining 3 terms, which is 2 times sine alpha times sine beta plus 2 times sine beta times sine alpha, sine gamma plus 2 times sine gamma multiplied to sine alpha. This is equals to 0. Now we will be rewriting the terms as, so we will take cosine squared alpha, add it to cosine squared beta and cosine squared gamma, and we'll keep all the terms containing cosine alpha, cosine beta and cosine gamma. So 2 times cosine alpha times cosine beta plus 2 times cosine beta times cosine gamma plus 2 times cosine gamma times cosine alpha. And then we have the remaining terms, which will be combining as sine squared alpha plus sine squared beta plus sine squared gamma plus 2 times sine alpha times sine beta plus 2 times sine beta times sine gamma plus 2 times sine gamma times sine alpha. So that's equals to 0. Now, immediately we observe a pattern here. We know for a fact that whenever we have a squared plus b squared plus c squared, and to it we are adding 2ab plus 2bc plus 2ca. So that's nothing but the expansion of a plus b plus c whole squared. So this is a known fact. So this was the whole idea behind our manipulation. So we can rewrite these 6 terms in a combined form as cosine of alpha plus cosine of beta plus cosine of gamma whole squared. And then we'll combine the remaining 6 terms as the expansion of sine alpha plus sine beta plus sine gamma whole squared, and that's equals to 0. So we have sum of squares that's equals to 0. So this means that either cosine alpha plus cosine beta, so both of them must be 0, not either, both of them must be equals to 0. And we must also have sine alpha plus sine beta plus sine gamma, only then the given equation will be true. We have 0 squared plus 0 squared, so that will be equals to 0. And this is what we were asked to prove, that cosine alpha, cosine beta plus cosine gamma must be equals to 0, and also sine alpha plus sine beta plus sine gamma, that must be equals to 0 whenever we have the given condition, which is cosine alpha minus beta plus cosine beta minus gamma plus cosine gamma minus alpha equals to -3/2. Hence proved.